Ganymede, Europa, Callisto. These are 3 of Jupiter's largest moons, but what do they have in common? All 3 of them are thought to have oceans of pure liquid water beneath their surfaces. However, before now, there has never been a dedicated mission to study these moons. But in the coming years, the ESA and NASA have both been planning missions to answer the questions we've had for years about these moons. We will soon know if they could be favorable for potential extraterrestrial life. Not only will this change our outlook on life on Earth, this could change our outlook on life in the universe. The Jupiter Icy Moons Explorer, JUICE for short, is a new spacecraft developed by the ESA that's designed to study 3 of Jupiter's icy moons, Callisto, Ganymede, and Europa. Launching on the 14th of April 2023, it will become the first spacecraft to orbit a moon other than Earth's. JUICE has many advanced instruments that will take crucial measurements of those 3 moons, and will also be able to take detailed photographs of the surface of each moon. According to the ESA, the main goal of JUICE is to, quote, characterize the conditions that may have led to the emergence of habitable environments among the Jovian icy satellites, with special emphasis on the 3 ocean-bearing worlds Ganymede, Europa, and Callisto. When JUICE arrives at Jupiter, it will enter an orbit around Ganymede. Ganymede is the most massive moon in the solar system, so this is the best option for the spacecraft. From this orbit, it will be able to make very close flybys of Europa, Ganymede, and Callisto. In all of history, there have only been 2 spacecraft to orbit Jupiter. The Galileo space probe, active from 1995 into 2003 when it dove into Jupiter, and the Juno spacecraft, active from 2016 until at least 2025. Both Voyages 1 and 2 also made a flyby of the Jovian system on their way out of the solar system. The Galileo mission was important in that its studies revealed that Europa, Ganymede, and Callisto all likely possess salty subterranean oceans. If they exist, each of these oceans are thought to have more water than on all of Earth's oceans. The existence of these oceans has sparked interest in the possibility of these 3 moons harboring life. Galileo also revealed that Ganymede holds its own magnetic field, being the only known moon to do so. This means that Ganymede's center is a large iron core that rotates, producing this field. This magnetic field is in fact strong enough to produce auroras that Juno has observed. Although both of these missions have given us information about Jupiter's moons, neither of them were dedicated missions to study these moons. JUICE, being many times more modern than Galileo, with much more advanced instruments, will be able to provide a never-before-achieved amount of detail about these moons. In order to probe these icy moons of Jupiter, JUICE is equipped with 10 instruments developed by different countries that will help answer the questions astronomers have about these moons. Let's briefly go over each of them and see what they'll do. 3GM will study the gravitational field of Ganymede, extent of the internal oceans, and the atmosphere and ionosphere of the icy moons. GALA will study the tidal deformation of Ganymede and the topography of the icy moons. JANUS is a high-resolution camera that will be able to take detailed images of the surface of Ganymede and create a map of Jupiter's clouds. JMAG will be able to characterize Ganymede's interaction with Jupiter's magnetic field and study the subsurface oceans. MAGIS will study the clouds and the atmosphere of Jupiter, along with minerals on the surface of the icy moons. PEP is a package of sensors that will characterize the plasma environment around Jupiter. RIME is an ice-penetrating radar which will be able to study the deep structures of the icy moons. This could potentially help astronomers understand where pockets of life might be able to exist. RPWI will characterize the radio and plasma environment around Jupiter. SWI will be able to investigate the thermal layers and the nature of Jupiter's atmosphere and the exospheres of the icy moons. And last but not least, UVS will be able to further analyze the thin atmospheres of the icy moons, study the auroras on Jupiter, and analyze the upper-level atmosphere of the planet. JUICE was launched on the 14th of April 2023 on an Ariane 5 rocket, the same type that launched the James Webb Space Telescope. JUICE deployed its instruments and antenna in the days following its launch. In the following weeks, it will be put into hibernation mode as it settles for the journey towards Jupiter. This journey will take about 7 years. To set it on the correct course, JUICE will perform some gravity assist flybys. It will make a flyby of Earth in August 2024, a flyby of Venus in August 2025, another flyby of Earth in September 2026, and a final third flyby of Earth in January 2029. Because JUICE will pass through the asteroid belt twice, a flyby of the asteroid 223 Rosa has been proposed, and this could happen in October 2029. JUICE will finally arrive at Jupiter in July 2031, where over the next 3 years, it'll make 21 flybys of Callisto and 2 flybys of Europa. The reason it'll make only 2 flybys of Europa is because of NASA's concurrent mission, which we will explore later in the video. Finally, in December 2034, JUICE will begin orbiting only Ganymede, where it'll make intensive observations for several months. In September 2035, if the mission is not extended, JUICE will be deorbited and crashed into Ganymede to end the mission. What JUICE is trying to achieve is historic, and this also means that there are risks and challenges that come with this mission. One of the challenges comes right at launch. As we've seen, JUICE is stocked with many instruments that are essential. In order to fit on top of this Ariane 5 rocket for launch, all of these instruments had to be folded up and stowed into a very small space. Typically, more moving parts increases the chances of something failing when JUICE unfolds. And in fact, for about 2 weeks after launch, JUICE experienced issues deploying its RIME antenna, although ESA was able to deploy it safely on May 12, 2023. Another challenge is that JUICE is traveling extremely far away from the sun, meaning it will receive much less solar energy. This is actually why JUICE's solar panels are so big, 914 square meters. Now let's look at NASA's mission, which will take an in-depth study of Europa. The Europa Clipper, or just the Clipper, is a spacecraft developed by NASA. As of May 2023, the Clipper has a planned launch date of no earlier than October 10, 2024, although this is subject to change. Like JUICE, the Clipper is equipped with key instruments that help it map out Europa's oceans, take high-resolution photographs, and more. Europa has long been known as one of the best candidates for life in the entire solar system, with life possibly residing in the subsurface oceans of Europa. It's important to note, though, that the Clipper is not capable of directly detecting life, but rather it will be able to analyze the conditions and environment of Europa to deduce whether or not life could theoretically exist. JUICE and the Clipper will be complementary missions to each other. They will both be doing their studies at the same time. Europa Clipper's antenna and solar panels will make it the largest spacecraft NASA has ever built for a planetary mission. Fully deployed, the spacecraft will span over 100 feet across. The Clipper will be orbiting very far away from the sun, so it needs a way to gather as much solar energy as possible. Also, Europa being the second closest of the 4 Galilean moons to Jupiter, it is very strongly influenced by Jupiter's intense magnetic field. The spacecraft will be designed with strong radiation-proof materials to protect the internal electrics from damage from this field. The intense radiation from Jupiter's magnetic field also plays into the spacecraft's orbital strategy. To further avoid extreme radiation, the Clipper will enter an elliptical orbit around Jupiter and position its orbits such that it flies by Europa every time it makes its closest approach to Jupiter. During this time, the spacecraft will make 44 flybys of Europa, making its crucial measurements each time. This type of orbit will also allow the spacecraft to observe a different part of Europa's surface each flyby. It will also be able to fly through the plumes of water that have been ejected from Europa's surface to analyze the ocean water. During its planned 4-year orbit, the Clipper plans to image 95% of the Moon's surface. Not only will this give a never-before-seen global map of Europa, but it will also be able to identify any possible landing areas. This will be an important footstep towards a future mission that could land on the surface of Europa. The Clipper is equipped with 9 instruments and 1 experiment that help it characterize Europa in detail. ICE is an imaging system which will be able to map Europa's surface with high-resolution images. Themis is an infrared sensor that will be able to detect warmer regions on the surface of Europa. MISE will be able to detect the composition of Europa's underground ocean and potentially detect biosignatures. Europa UVS will do the same thing as MISE, but with ultraviolet light. MASPEX will collect samples of Europa's water geysers and analyze their composition. SUDA will study the dust particles that come off Europa from micrometeorite strikes and analyze the surface composition. REASON is an ice-penetrating radar similar to RIME on JUICE, and will probe the subsurface structure of Europa. PIMS will analyze Europa's interactions with Jupiter's magnetic field. ECM will be able to characterize the salt content of Europa's oceans and the thickness of the ice shell by measuring magnetic interactions. And a gravity radioscience experiment that allows scientists to characterize the gravitational disturbances within Europa. Europa Clipper is scheduled to launch no earlier than the 10th of October 2024 on top of a SpaceX Falcon Heavy rocket. The spacecraft is expected to follow a Mars-Earth gravity assist trajectory, or MEGA, meaning that it will make a flyby of both Earth and Mars on its way to Jupiter in order to set it on the correct path. It's expected to make a flyby of Mars in February 2025 and a flyby of Earth in December 2026 before arriving at Jupiter in April 2030. Over the course of 4 years, it's expected to make 44 close flybys of Europa, ranging from 25 kilometers to 2,700 kilometers above the surface of the Moon, enabling it to take high-quality photos of the surface. It's important to note that neither JUICE nor Europa Clipper will be directly capable of detecting life on any of these moons. Instead, these probes will be able to study the conditions and geography of these moons, and we can use this data to determine whether or not life as we know it could exist. The concept of a subterranean ocean is not as rare as we might have thought. Astronomers recently announced that upon analyzing old data of Uranus's moons from the Voyager 2 mission, Titania, Oberon, Ariel, and Umbriel also likely have subsurface oceans similar to Jupiter's icy moons. These oceans might also be warm enough to support life, warmed by geological activity. Ceres is a large asteroid and may currently have a subsurface ocean, or may have had one in the past. The icy moons of Saturn, specifically Titan and Enceladus, are also good candidates for life in their own right. There are many more examples. The point is that there are many places in the solar system where life could exist, or could have existed in the past. Ultimately, the existence of life within our own solar system could point to life outside of the solar system too.